Good morning, one and all. Myself, Dr. Srinivas Bachu, Associate Professor and HOD of EC Department. In the last 5 sessions, we discussed about set theory, probability theory, basic concepts, and the total probability and Bayes theorem. Now today we will see the tutorials on the joint, conditional, total probability theory and Bayes theorem. First we will cover the tutorial on the Bayes theorem. In 3 boxes there are capacitors as shown in the following table. Experiment consisting of the 3 boxes. Randomly selecting one box, each box has same probability. And selected a box, choose one capacitor. This is the given data. 2 questions are here. What is the probability of selecting 0.01 microfarad capacitor? Given that box 2 is chosen. Conditional probability it is there. If 0.01 microfarad capacitor is chosen, what is the probability that it came from the second box? 3 boxes are there. Capacitors is there. Capacitor is different event. Okay, now we will see the one by one. First, we will note down the given data, whatever they given. Let us consider A1, A2, A3 are 3 boxes, has same probability. So 1 of 3, 1 of 3, 1 of 3. So P of A1 equal to P of A2 equal to P of A3 equal to 1 by 3. Each box has same probability, equal probability. First question is, what is the probability of selecting 0.01 microfarad capacitor? Given box 2 is chosen. Now first we will see the sample space. In which box? Box 2. In box 2, how many number of capacitors are there? 80 plus 35 plus 90. Total is 210. So in the second box, this is already happened. So 210 capacitors are there. CB the event 0.01. Wyman says I am interested on this event. So probability of the selecting 0.01 microfarad. So P of C. Okay, now the probability of selecting 0.01 microfarad capacitor, that is P of C. My question is here, P of C given as box B2, that is A2. This is P of C by A2. This is my question. Now one of the event, okay, now P of C by A2. A2 boxes already happened. In A2 box 210 capacitors are there. 210 capacitors are there, and different types of the capacitance are there. Out of this one, 95 are, okay, now out of this one, can you see this? This is 95, 0.01, okay, now 0.01 capacitors are 95 are there. 0.05 capacitors are 95 are there. This is 95. So out of 95, I am selecting one capacitor. Is 95 C1 ways, and out of 210 capacitors, I am choosing one capacitor from this lot is 210 by 210 C1. So the probability is the favorable number of cases to the total number of cases. I am choosing one capacitor, that should be the 0.01 from the box 2 is 995 C1 by the 210 C1. So answer is 95 by 210. The second question is here. If a 0.01 microfarad capacitor is chosen, what is the probability that it came from the second box? What is the probability that it came from the second box? Let P of C be the selecting 0.01 capacitance. By using total probability theorem, we get P of C equal to, Wyman says now I want P of C. P of C equal to summation I equal to 1 to K P of, okay, and that formula I can use and applicable into this event, that is C by A1 into P of A1 plus like this, so on, so on. C be the different event, then A be the different event. Instead of this A1, A2, A3, we are taking B1, B2, B3, B sub k. So this is total probability. Now find out one by one. P of C of A1, P of C by A2, P of C by A3, and P of A1, A2, A3 are equal probabilities. Right, P of C1, C by A1. Selecting 0.01 given as box A1. In box A, 20 0 point, okay na, 20 capacitors are there that are 0.01 type. So out of this 20, I am selecting one capacitor, 20 C1 ways. But in box A1, how many are there? Box A1, 20 plus 55 plus 70. So it is 20 by 40. So this is a probability of the selecting 0.01 microfarad capacitor given in box A. The same manner in box 2. So box 2 already we mentioned 95 by 210. Okay, 95 are 0.01 microfarad type. Total is 210. This is 95 by. In the same manner, can you perform, okay, in box 3? So in box 3 is given probability of C by A3. In box 3, 25 are 0.01 microfarad type. Totally this one. Simplify this, we will get P of C by A3. Now find out P of C by using total probability theorem. Substitute all the values and simplify, we will get the P of C values. If a 0.01 microfarad capacitor is chosen, then what is the probability that it came from the second box? I want the probability of the second box by using Bayes theorem. That is P of second box, probability of the second box given as C, that capacitance. Already 0.01 is happened. What is the probability that it came from the second box, it seems, A2. So then use Bayes theorem. So Bayes theorem means as A2 by C equal to like B sub k by A equal to formula. Apply these things, simplify. The C is a different event, that is a 0.01. Different capacitance I choose to. That is P of C. P of C already I got it. It's a total probability. So now substitute these all values and simplify 0.0656. So this is a A2 by C. So in this way we will get the total probabilities and Bayes theorem. Ultimately we covered some of the conditional cases here, indirectly some of the probabilities we covered. So this is a Bayes theorem applicable in these things. We will see one more problem. Discuss joint and conditionally. We know about the joint and conditionally. Of 3 men, the chances that politician, businessman and academician will be appointed as a vice chancellor of university are 0.5, 0.3, 0.2 respectively. Probability that the research is promoted by these persons if they are appointed as vice chancellor are respectively mentioned. Now determine the probability that research is promoted. If research is promoted, what is the probability that vice chancellor is academician? Now we'll see the one by one. I consider 3 events. One is a politician, one is a businessman, one is academician. For these 3 things, I have taken, for these 3 persons, I consider as events A, B, C, respectively politician, businessman and academician. Means C is the academician. Will be appointed as a vice chancellor of 3 men. I am considering the V also the event, it's a vice chancellor. Given data, the probability of the politician, businessman, academician, respectively 0.5, 0.3, 2. The probability that the research is promoted, is the given if they are appointed as a vice chancellor. If they are appointed as a so the probability of this one, the probability of the vice chancellor given as politician, given as businessman, given as academician. The probability of the vice chancellor given as politician, given as businessman, given as academician. So this probability they given. So they gave everything. They gave everything. Now the B is a event vice chancellor. I consider. Now question is here, the probability that the research is promoted. If they are appointed as a vice chancellor. So now question is here, probability of the vice chancellor. The probability of the vice chancellor is equals to by using total probability theorem. So by using total probability theorem, vice chancellor is a different event, and academician, politician, these three types of the events. Out of this, one is the vice chancellor, is a different event of my sample space. Using Bayes theorem, find out and substitute all the values and simplify, we will get the PFP. Now the probability of that research is promoted when the vice chancellor is an academician. And the vice chancellor is an academician. Probability that research is promoted when the vice chancellor is an academician. Vice chancellor, this is given. The given, it's happened, occurred. The probability of this C means as academician. So academician by V. So by using Bayes theorem, I am writing here. Okay, na? Bayes theorem formula. Apply this thing. The denominator polynomial, denominator thing is called, it's a total probability, it is a P of C. Already we got it, no need to find out, that is a 0.52. Once again you want to find out, you can find out. Simplify. So this is the total probability and Bayes theorem, like this will take. Many examples will take, many things will take. But need to identify which is different event, which are the events of the sample space. So we are finding or we are estimating, okay, na, the probability of the one of the event by the different event. Okay, na, P of B suffix K by A. A is a different event with respect to the sample space. The last problem we will see here. A box contains 3 coins. One is a fair, one is two-headed, and one is a weighted coin. So that the probability of the head appears is 1 by 3. A coin selected randomly and tossed. Find the probability that head appears. Head probability I want. I am selecting one coin, tossed. Now out of the given data, box consisting of the 3 coins. One is a fair coin, one is a two-headed coin, another one is a weighted coin. So these 3 coins are there. One is a fair, one is a weighted coin, and a weighted coin. Now these 3 coins are there. Okay, now 3 coins are there. 3 coins means as the probability of the each coin is 1 by 3. 1 of 3, 1 of 3, 1 of 3. So now coming to the fair coin. Fair coin having head and tail. So head probability and tail probability is must be equally likely. The next one weighted. Okay, na, two-headed. Both sides it shown head. That is a two-headed coin. When we are tossing this coin, when you are tossing this B coin, always it will show head only. Why means both sides head is there. 100% happen. The probability of this head appears is 1. And weighted coin. Okay, weighted coin. Head and tail is there. Weighted, okay, here mentioned one coin is weighted, so that the probability of the head appears is 1 by 3. They given here head probability 1 by 3 weighted. So success, let us assume this is success. Success P equal to 1 by 3. Okay, now what is failure? Q equal to 1 minus failure, 1 minus success. So 1 minus 1 by 3. So simplify this, will get 2 by 3. That is the failure probability is tail probability is the 2 by 3. Therefore, the probability that head appears when selecting a coin randomly and tossed, probability that head appears. Suppose I tossed this coin. Okay, now this coin probability is 1 by 3. Head appears is 1 by 3. So 1 by 3 into 1 by 3. Or this coin tossed, head probability, so 1 by 3 into 1. This coin tossed, head probability 1 by 3. So simplify this, will get, this is the probability of the head appears. Okay, now 3 coins are there, one coin selected randomly and tossed this. Thank you all. Any doubts, contact, send a mail. Thank you.